In today's video, we get to talk about a really cool application of exponential functions in the world of finance. And that is this concept of amortization. And some of you guys may have heard it if you've taken any sort of economic class or anything like that. But if I were to put this simply, amortization really is just talking about how do monthly payments work? How are they calculated? What's the math behind monthly payments? And that's what amortization is. So that's what we're going to talk about today. So, monthly payments come when you take out a loan. And if you take out a loan, of course, you're charged interest on that loan. And so my formula for my loan ends up being really similar to my formula for investing money into an account, right? When you invest money into an account, you earn interest. And the money in the account grows. When you take out a loan, whoever gives you that loan charges interest on the loan, and so your loan gets bigger over time. So I can calculate the size of my loan by using my general kind of exponential formula. P naught is going to represent the initial loan amount, right? My starting value of my loan. But then I'm actually going to use the compound interest formula, which I'm not sure we've talked about yet in this in any of our videos, but the compound interest formula looks something like this. 1 plus r over n raised to the n times t. Where does this formula come from? Okay. Well, first of all, the 1 represents 100%, right? When you're charged interest, you still owe 100% of the original loan that you took out. You still owe 100%, but you also owe an additional amount based off of the interest. Okay, so that's where that 1 comes from. R is going to be the interest rate, right? Because you're going to owe 100% plus that whatever, like 2, 3, I guess this is loan interest, so it's usually higher, right? 6, 7% interest that they're charging you. You are also going to owe that much as well. But then this n is the number of times the interest is compounded. And that means how many times do they actually charge you the interest? Usually your interest rate is given in an annual interest rate. So total over the whole year, what percentage are they going to be charging you? But then they break it up into smaller amounts that are happening multiple times in a year. And that's that idea of I'm compounding this interest. With monthly payments, guess what that end value is, right? With almost all the problems you're going to work on in this chapter, your n is going to be 12 because you're compounding the interest monthly. Every month they compound the interest and charge you. Okay. So by dividing the rate by 12, it breaks up that rate into how much are they going to charge each month. And then you'll notice that it's also up here in the exponent because if they're going to charge you each month, they're going to charge you a less amount, but they're doing it 12 times in 1 year. Okay? T is going to represent how many years are going to pass. Okay? And so if you think about it, n times t is just going to be the number of months. How many months are you going to be paying? How many times are they going to charge you interest? So that's my compound interest formula. And that's going to be a big part of this amortization because we need to know how much the loan is actually growing. But the other part of this is the fact that I can pay off my loan. I can pay off my loan through monthly payments, right? Usually that's how you pay off loans. You usually don't. Most loans, right? It's not like you get your loan, let it grow a little bit, and then pay the whole thing off. Usually when you take out a loan, you have a payment plan of how you're actually going to pay for it. So that's the other part of this formula. There's another side to this. Okay, So we're going to introduce this variable lowercase p, which is going to represent my monthly payment. How much am I paying each month? Okay, and I can multiply that by the rate at which my loan is growing. Oopsies, it's supposed to be a bracket. And I'm not going to lie, I don't fully understand this formula. I just know that this formula represents how your monthly payments factor into how your loan is growing. Okay, this is my what's called annuity. So that's the fancy term behind this. And overall, it represents how monthly payments affect how much you actually owe. Okay? And how your monthly payments are affected by your interest. So, most of the time, we might be wondering how long I guess what this does is this introduces a lot of different questions that we can now answer. These two terms will let us answer questions like, okay, if I take out this loan for this amount of time, what's my monthly payment going to be? Or if I plan to take out this loan and pay this much per month, how long is it going to take me to pay it off, right? It lets me answer those questions by simply setting these two equations equal to each other. Because what that does is that calculates when will my total payments end up equaling my full loan amount. Meaning I have completely paid off my loan. And that's what this formula does. And this right here is amortization. This formula together. Okay? So this is the formula you're going to be using on pretty much every single homework problem in this chapter. Okay, is you're going to be using this formula. Okay? And like I said, if we know that this is monthly payments, anytime it mentions that word monthly, we already know what my end value is going to be. If it's monthly payments, I can go ahead and just put 12 in for n anytime I see an n. Okay, so that's my amortization formula. So let's look at a couple examples where we get to use this. Okay, so let's look at our first example. When we're going to do car shopping, we're going to go car shopping here. So let's say we go car shopping, we find a car that we like, costs $20,000. That means since I don't have that money on me right now, I'm going to need a $20,000 loan. But let's say we do have enough on us to do a 30% down payment. Okay, what does that translate to? Let's see, 30% of 20,000 is 6,000. So we have enough to make a $6,000 down payment. And then we shopped around and we found the best interest that we could find with a 7% interest compounded monthly. Now you'll notice that when you look for interest rates, sometimes those interest rates are dependent on how long you're going to be paying. A lot of times banks or loaners are more willing to give you a lower interest rate if you plan on paying for longer periods of time, if you extend your loan. So you only found 7% interest compounded monthly if you agreed to pay for 5 years. Okay, so that's what you're able to find your interest rate for, was for a 5-year loan. So we have a 5-year loan at 7% interest compounded monthly. So with this information, I can go ahead and actually set this up in my amortization formula. Okay, first off, let's point out some things. First off, I see the word monthly. What does that tell me about my end value? N is equal to 12, just like we expected. My end value is equal to 12. Okay. Well, if I wanted to start writing this, what's my P naught? What's my loan amount? It might be very tempting to say, oh, $20,000, that's what my loan's for. But remember, we put $6,000 down. That means I don't have to worry about borrowing the full $20,000. I'm only borrowing, right? 20,000 minus 6,000, I'm only borrowing 14,000. So that's my P naught. That's what I'm actually borrowing. Okay? So I get 14,000 times 1 plus, what's my interest rate? 7%. So I'm going to put 0.07 divided by 12 because it's happening, they're charging me every single month. So they're breaking that 7% up into 12 pieces. Okay? Raised to the, because they're breaking up into 12 pieces, they're going to charge me every month. But wait, we have a T value, right? How long am I going to have this loan for? This 5 years represents my T value. So I can go ahead and plug in 5 for T. Well, that takes care of how my loan is going to grow. And now on the other side, I can talk about, well, how quickly am I going to be paying this off? Lowercase p. That's the one piece of information I'm not given. That's the one unknown still here is what's going to be the size of my monthly payment. So guess what we're going to be solving for? We're going to be solving for lowercase p. But then I know the rest of this. 1 plus 0.07 divided by 12 raised to the 12th times 5 minus 1 all over 0.07 divided by 12. Okay. I can go and start calculating this out. Okay. When I do 0.07 divided by 12, I get 0.00583 repeated. 12 times 50, or 12 times 5 is 60, equals my monthly payment times, I'm getting the same thing up here, 1.00583 repeated, raised to the 60 power minus 1 over 0.00583 repeated, right? Because that was what 0.07 divided by 12 is. I can keep going, but I do want to point out this 60. What does that 60 represent? That means that's the number of months I'm going to be paying this loan. 60 months. I'm going to have this loan for 60 months. Okay, let's keep going. I mean, I can still just keep going, plugging things into my calculator, right? So if I do that left side, when I raise that to the 60th power and then multiply by 14,000, I get 19,000, oopsies, 846.75, and I'm going to round it a little bit. Now, even though you really should get in the habit of not rounding until the very end, but I'm going to round this just because I want to talk about this value and what it means. So before we get into the annuity side, let's just talk about this value, 19,846.75, and I'm going to give you a clue here, cents. What is this value? This value, once again, if I'm ignoring my payments, this value represents how much would I owe in 5 years if I didn't make any payments. My $14,000 loan would end up being almost a $20,000 loan in 5 years if I just ignore it and not make any payments. I would then owe almost $20,000 instead of $14,000. But thankfully, we plan on making payments here. So I'm going to have P times, and you'll notice that the rest of this, I can go and combine all together. I can throw this in my calculator and get a value out. And I get 71.59290165. Once again, the reason why I wrote all that out is because, in general, don't round until the end. Okay. I'm not sure if this has any meaning, so we're not going to worry about it. We'll go ahead and just finish this off by dividing. So now I'll go ahead and divide by 71.59 ... Divide this side by 71.59 ... And I get P is equal to about, I do have to round this, but in order to make it into a meaningful amount, I get about $277.22. And that is my monthly payment. That's what you're going to end up paying every month. Okay, any questions? If you're curious about where I got the 71.5929, that's just from doing 1.00583 raised to the 60th power minus 1. You can plug all that into a calculator and then dividing that by 0.0583. You can plug all that into a calculator in order to get that. Okay, well, now that I have my monthly payment amount, what's really cool is I can actually now look at how much do I actually end up paying over the course of these 5 years. So if I'm paying this monthly payment for 5 years, once again, that's what that 60 is. That means I'm paying that payment 60 times. I'm making that payment 60 times. So what I can do is I can take this $277.22 and multiply it by 60 to calculate the total amount I'm going to pay over the course of these 5 years. And I get $16,633.20. So by not paying the $14,000 all at once, right? By not paying for the car completely, by taking out a loan, notice how much do you actually pay in interest? If I subtract $14,000 away from that, I end up paying $2,633 in interest. $14,000 was for the car. The rest was because you took out a loan. You end up paying $2,633. Right? That's how banks make money. Is because so many of us don't have the capital to purchase things outright, and so we have to take out these loans, and they make money on the interest. Anyway, okay. Let's look at another example. Okay, for our next example, let's do the opposite. Let's say I know how much I can afford to pay each month. What size loan can I actually take out? Okay, so let's say I've got a much tighter budget and I can afford to pay $100 per month. That's how much I can afford. But I can only afford to do that for 2 years. After 2 years, I have more plans. I'm going to need that $100 for something else, right? Maybe I want to buy a new car, or maybe I want to actually start saving for a house or something like that, right? I can only pay $100 a month for 2 years. Well, because that's such a short loan amount, or because that's such a short time for a loan, the best I can get is 9% interest. Okay? The bank's got to win somehow. So if you shorten your time that you're paying off, they're going to increase your interest rate. Okay. So what do I not know in this situation? Well, first of all, this represents my lowercase p, my monthly payment. This represents my time. And this represents my rate. Notice what I didn't tell you. How many times you're compounding it? Well, guess what? We're going to go ahead and assume that n is equal to 12. Right? We're going to assume this is monthly payments like normal. Well, I guess, heck, that's what this tells us, right? This tells us my n is going to equal 12. Okay, so let's set up my amortization formula, but this time, I don't know P naught. That's what I'm going to solve for. I'm going to solve for what size of loan can I actually take out here. Okay, but then I do know everything else. So, parentheses. 1 plus 0.09 divided by 12 raised to the 12 times 2 equals, I do know my monthly payment amount, so I'm going to plug that in for P, for lowercase p. 100 times 1 plus 0.09 over 12 raised to the 12 times 2 power minus 1 all over 0.09 divided by 12. Okay, so now I've plugged everything into my amortization formula, right? I should have used different colors so you could see it, but there's my rate, there's my rate, there's my rate. Oh, dang it. Sorry, red was years. There's my monthly payment. There's my rate. Rate. There's my years. And there's my compounded monthly. See that in a lot of different places. Okay, so let's go ahead and plug all this stuff in. See what we get. Okay. Once again, so much of this you can just plug into a calculator, right? This whole side of the equation right here, you can just plug that into your calculator. I mean, be careful about what order you put it in, right? Because you've got these brackets to kind of show you what order. I mean, so start with what's inside here, plug that in, multiply it by 100, then divide by 0.09 divided by 12, right? And then you can do this side. And when you're done with this side, just divide it over, and you should get P naught is approximately 2,188.91. Okay, this tells me I can take out approximately about a $2,000, almost $2,200 loan. And my monthly payment's going to be right around $100 if I do that. Okay. Good luck on the homework. Let me know if you have any questions, and I'll see you in the next video.